Hey, and welcome back to another video. And in this video we're going to see how we can update our app to use Swift concurrency. So we're going to be looking at how we can refactor our existing code, which is using closure based asynchronous code, and use the new built-in Swift concurrency functionality. We're mainly going to be looking at this specifically just for the networking part of our code, like I mentioned before. So what are the benefits of using Swift concurrency? Well, it's easier code to write, first of all, as well as read and maintain, and it's safe in terms of handling error case paths. So you want to learn more about Swift concurrency, then you can check out the free course on my channel. So let's first of all start off by refactoring our networking manager. So if you just go into the networking manager file, you'll notice if you just scroll to the top that we actually have our request, and right now it's using closure based syntax here, and it's also using closure based syntax when we tell URL session to kick off a request. Now we're going to actually update this now to not use this anymore and instead use the Swift concurrency syntax. So the first we need to do is actually mark our request function as asynchronous. So let's just first of all remove our closure. And then here, after here, we're just going to say async. So now our function is asynchronous. So you actually look at our code here. We actually have our completion closure where, it used to be. And we called failure within the result type. Now, when you're working with Swift concurrency, you don't really have a result-based closure per se. So what you can do instead is actually throw an error. So after our async, we're going to mark it with throws like so. But we're not going to do that right now because there's actually some error cases here that we don't need to handle because Swift concurrency makes our lives a lot easier. So in order to actually see how it makes our lives easier, we're first of all just going to refactor the code that we wrote to actually execute a network request. So I'm going to type this out and then we're going to just break down what this means. So after our request here, we're going to say let data response, and then we're going to say try await, and then we want the URL session dot shared data for request, URL request here, and we'll pass in our request. So what's going on here essentially is that we're basically saying here that we want to try, so this function here can actually throw an error, so we're going to try to fetch some data and we're going to await the value. So this await is essentially a suspension point where you tell the system that something asynchronous is about to happen, and it will actually suspend and wait for it to finish. So if you realize here as well that we actually have a tuple. So when you're working with this function, it actually returns a tuple where you can access the data and the response that you got back from the request. Cool. So if you just look at this compared to the closure, you can see that this is already a lot more easier to read and it will be easier to follow. Now the next thing we're going to do is actually start to refactor and rip out some stuff that we do and don't need. So we'll start from the top. So like I said before, because we don't actually have the completion anymore, we don't need this failure. Instead, we just need to throw this invalid URL error. So let's do this now. And because we're throwing an error, we don't need to return anymore. Cool. So we'll leave our build request because that's fine, and we've wrote our new function here to actually execute the request. So the next thing we want to do here is we actually want to check to see if the response falls within a valid range. So like we had in our closure before where we checked to see if there was an error, we don't really need to do this anymore because our function here will throw any errors for us, so we can handle that outside of the networking manager class. So let's just copy the code that we have here for checking the status code. And then we're just going to tweak this a bit because we don't need this completion. Instead, we just need to throw. And we don't need to return, like so. Cool. And then after we check the response from our networking, we actually need to write the code in terms of doing our decoder. So we just want to copy the JSON decoding and just paste that below here. Now the reason why I'm not pasting this data and the catch statement here is because if you look at the JSON decoder, it actually throws an error as well. So if something goes wrong, we're actually able to just throw the error and handle it from outside of this function. So we don't need these two anymore. So after this, that's it. So now we can actually remove all the code that we had that was referencing the data task. So let's just remove this. And if you just look at this, you should now see that it's actually a lot more easier to read, and it's also reduced the line of code that we had before. But one final thing we do need to do is actually return the result. So you'll see here that we're not actually using our decoded object. And in order to actually return some kind of value when you're using async await, is you simply just need to return with the function. So after our throws, we're just going to specify the return should be t, like so. And then after our res, we're just going to say return res, like so. Cool. And that's it. So now if we just go over this again before we refactor our next function, we check to see if the endpoint URL is valid. If it isn't, then we're going to throw an error to say that it isn't, valid. Then we build our request, and then we write our code where we say we want to try and execute a fetch request and await the value. Then we access the response to check if it's within a valid status code. If it isn't, then we're going to throw an error. And then finally what we do is we then try to decode our object using the JSON decoder, and if everything's all good, we'll return the value, or else we'll throw the error from this function. Cool. So this is a lot more easier to read compared to using closure-based syntax. So the next thing we're going to do is refactor our request function below, but this is going to be a bit different because we don't need to actually return a value here because this is actually void, so it doesn't return anything. So instead, this is going to be an asynchronous function that simply throws an error. So let's take this out. And then we'll just type async and then throws, because we don't need to return anything like I said before. And then we're just going to cut some stuff from here. So our URL endpoint, we're just going to copy this and replace it with this. Cool. And then we're just going to copy this here, paste it above. And then after our request is made, the only thing we really care about is whether it's within a successful status code. So we simply just need to copy this guard statement and then paste it in here. So if it's not within a valid status code, the function will throw some kind of error. If it is within a valid status code, then we just want to let it continue and nothing will happen. Cool. So this is all we need. Sweet. So like I said before, if everything is okay, what will happen is it will actually continue execution after the function is called. Now you'll see that we're not actually using this data property here, so we don't need to actually access it. So in order to, remove it, we can just use an underscore here because we're not actually using the data property like so. So now that we've done the refactor here, we essentially now need to actually refactor our view models to use the new Swift concurrency syntax that we've wrote. Now we're going to tackle our people view first, and then we'll look at our details view, and then finally we'll tackle our create view because this is a bit different towards the end. Let's go into our people view. As I say, people view model, and you can see here we don't actually have a closure anymore. So instead of having this closure, we need to refactor this. So for this fetch users function, we actually need to convert it to be an asynchronous function. But what we're going to do is we're not actually going to make this fetch users function throw any errors. We're going to handle any errors within this view model. So all we need to do first of all is mark this function as async. Cool. Now what I'm going to do is actually just type this out fresh again, and then we'll just break down line by line what's going on. So what I want you to do is everything within this function, I essentially want you to delete it so we can just start fresh again and just go through it line by line in terms of what we're trying to achieve. So the first thing we want to do when you try and fetch a user is actually set is loading to true. Cool. And then after finish setting is loading to true, then we want to actually write a defer to basically set its loading back to false. So what this is going to allow to do is make sure that after everything within this function has completed, we always reset the is loading back to false. Cool. So the next thing we need to do is we want to basically catch any errors that are thrown by our networking manager when we make our network request. So we're going to need a do catch. Cool. So we'll handle our do bit where the happy path where everything is okay, and then we'll handle the error handling within our catch statement. So within our do, the first thing we're going to do is try to await the response that we get back from our networking manager. What we're saying here is we want to try to fetch the user's response from the user's endpoint, and we're going to await the value. So it's worth noting here that we specified the endpoint like we did from our previous video, but we've also specified the type that we want our response to be decoded to. Now what we want to do after this is actually set our users array to the value within our response.data. So let's do that now. So when you're working with async await, like I said before, when you say await, what's happening is you're basically marking this as a suspension point. So what's going to happen is the system's going to wait for this to finish before it moves on to the next line. So in our case, it's going to wait to get a response, and then we're able to access the data property from that response and set that to our users. So as you can see, compared to before when we were working with our closures, this is already a lot easier to read and understand what's going on. So the next thing we need to do within our catch statement is actually handle the errors. So the first thing we want to do is actually set that there has been an error. Cool. And then within our, we want to handle both kind of errors that could be thrown by our networking manager. Now when I say both kind of errors, what I'm talking about is either a networking manager error or if it's actually a system error. Because if you go into our networking manager, you'll realize that because we've now refactored this, we actually don't always specify that this could return a networking error. So examples of this can be seen here on this line where we just say try, and this line here where we say try. So these type of errors that these two could return are not explicitly networking manager errors. It's only here where we actually say to throw a networking error. So let's go back here. And we're going to do some typing. So we're going to say if let, and then we're going to say networking error is equal to error as networking manager dot networking error. Then we're going to set the error as the type here, which is networking error, because it's the same type. Or else, if it isn't a networking error, then we're going to set the error as a custom error, like so. So we're still able to access the value from our error. Cool. So now we've wrote all the code that we need for our people view model in terms of, fetching data and handling the errors within this file. So the next thing we want to do is actually use this function within our people view. So if we go into our people view, you should see that we actually have a few errors here, and that's because we're trying to use an asynchronous function from within a non-asynchronous context. So the first thing we're going to look at is the onAppear, and then we'll discuss the button. And I'm actually going to just talk to you about two ways to basically kick off an asynchronous function. Now in our onAppear, what we could do is use a task closure and then say await vm.fetch users. So this is kind of valid, but it's actually not the recommended way of kicking off tasks when you want your view to appear. So what you actually should do is when your view appears is use the actual task modifier that comes with SwiftUI views, because what it actually does is it allows you to basically kick off an asynchronous task when the view appears, and it will also automatically handle canceling tasks for you when the view disappears as well. So what we want to do is remove this from here, and then instead of on appear, we're going to replace this with task. So now we're using the task modifier to kick off our asynchronous call. So we're simply saying to the task that we want to await and fetch some users. Now, in situations like this within the button, you're not able to actually use the task modifier in this example here. And the reason why is because within our button, we're actually saying that when someone taps on it, we want to execute the asynchronous function. So in these situations, what you want to do is actually use the task closure that I showed you before. So when you're working with SwiftUI views, if you're working with a view where you want to execute an asynchronous call when the view appears and disappears, for example, then you want to use the task modifier. Or if you're working with a view where you want to actually trigger a asynchronous call based on some kind of action, i.e. like a button tap or a gesture or whatnot, then you want to use the task modifier. So that's the difference for when you want to use both of them. So now that we have this in place for our people view, this is looking pretty good, but we need to apply the same rules to our detail view model. So let's go into our detail view model. And I'm just going to put both our detail view model and our people view model up side by side. And one thing you should realize just by looking at them is that they're both literally the exact same. So the only thing that's different is that we just changed the enum case that we use for our networking manager request. So to speed this up, I'm just going to simply copy all the logic that's within here and simply just paste it within this function. One thing that you'll want to do and make sure so you don't forget is actually change the way you handle the response within the do catch. So just to do that, let's just close this. And then now, rather than us trying to request people, we're now going to try to fetch a user based on their details. So we're going to change this to .details and then change this to ID. Also, the type that we try to decode it to is going to be a bit different as well, because it's actually the user detail response that we need. And if you look here, we actually set the user detail response directly to this published property here. So we actually don't need this response here like so. Instead, we can just directly say self.userinfo is equal to that, like so. Cool. And then finally, what we need to do is, because right now our function hasn't been marked as async, we need to mark this function as asynchronous. Cool. So now all our errors have gone away and this is looking good. So within our detail view, we now need to change our onAppear to now be a task. And we want to use await. And then that's pretty much it. So we've got one more view model to change, and that is our create view model. Now our create view model is a bit different because if you go inside of it, it doesn't necessarily have the is loading, and also as well we actually catch errors because of the validation that we did from our previous video. So in this example that we're going to do here, we're actually going to treat this one a bit differently compared to our other ones. So let's actually type this one out again fresh so we can just walk through what's going on. So let's do that now. So again, let's just delete everything that's within this create function so we can just start off fresh, and then we can just talk through what it is that we're going to do. So the first thing we need to do is, before we even make our request, we want to do some kind of validation on the information that someone has typed into the form on the screen. So we're going to need a do catch. Cool. So like I said before, because we do the validation, we're going to use our validator to validate that person. Cool. Now for this, what we're going to do now is just handle the happy path, and then similar to like before, we'll handle the case statement. So after we try to validate the person, the next thing we want to do is actually set the state that it's currently submitting. So this tells our view that we're currently submitting some data. Then we want to encode the data that someone has inputted in the form into some kind of data that we can send within our network request. Cool. So as you can see, we're just using a JSON encoder to help convert our new person from a codable to some data, so we can associate this with the API request that we send to the service. So the next thing we want to do is actually try to send this data. Now we don't want to use the function where it actually tries to decode some kind of object when you make a network request. Instead, we want to use the alternative function we have in our network manager that simply just executes a request and throws an error if something goes wrong. So we're going to say here try await, and then networking manager.shared.request, and we want to use the second one where we don't actually have our type that we want to decode it to, and the endpoint here is going to be .create, and then the data is going to be the data that we want to submit. Cool. And then finally, after all of this, what we want to do is set the state to be successful. So if we submit this data to the API and it doesn't throw any errors, then we're going to move on to this line, and then we're going to set the state to be successful. Now we'll get an error because we've not marked our create function as asynchronous. So to get rid of this error, let's just mark this as async. And now you should see that the error on the line goes away. Cool. So now we've got our code here for validating the person, setting the state to be submitting, encoding our data and submitting our data, and then setting the state to be successful if everything is okay. What we now need to do is actually handle any errors when something goes wrong. So within our catch statement here, we're going to say self.hasError is equal to true, like so. And then we're going to try to cast the type of error that we're getting back to then handle that within our form. So let's do that now. So to handle this, what we're actually going to do is use a switch statement and check what type of error it is that we're dealing with, because there's 3 types of errors we need to handle. So we need to handle a networking error, and we need to handle a create validator error, and we also need to handle a custom error if it's a system error as well. So first of all, what we're just going to do here is we're going to add in a new case to our form error, and we're going to say system, and then we're going to say error, localized error. Cool. So that's a third new case that we can, a third new type of error that is possible for us to throw onto the screen. So let's type this out. So we're going to say switch on error, and then we're going to say case is, and then we want to check what type of error it is. So if it's a networking error in our networking manager, then what we're going to do is actually we're going to set the state to be unsuccessful. And then after setting the state to be unsuccessful, we're then going to set the error to be a networking error, and then we're going to say that the error is as a networking manager dot networking error, like so. Cool. So now that we've handled the networking error case, the next case we want to handle, like I said before, is the validation state. So let's do this. So we're going to set the state again to be unsuccessful, and then we're going to say self.error is equal to, this time rather than it being a networking error, it's going to be a validation error, and then we're going to say error as create validator dot create validation error. So before we actually move on to our default case, you'll see that we've actually got a bit of repetition here in terms of us setting the state to be unsuccessful. So rather than us doing it for every single case, let's actually just extract this out, and then we'll just move this outside underneath our has error. So all we do within our switch statement is just set the error based on the type of error that we get back from our catch. And then finally, we need to do our default. So our default is going to handle any kind of system errors. So we're going to say self.error is equal to dot system and then error, like so. So one thing you'll realize here is because we've used the system error, it can't conform to localized error. So rather than this being localized error, I'm just going to change this to be error, like so. And then what's going to happen here is that within our switch statement, we now need to say what we want to use for the error description for our system error. So for this case, system, we're simply going to use the localized description rather than the error description, because we just want to use to get the system's description of what's going wrong. And then we're just simply going to return that. Cool. Sweet. So now we've handled our error case. So we're saying here within the catch statement, we're going to set the has error to be true. We're going to set the state to be unsuccessful. And then we're going to switch on the error. And depending on the type that it is, we're going to set the error property to be the valid error case. So now we need to actually hook this up to our create view. So let's go into our create view. And then within here, because we're not within a SwiftUI view that can appear, we're going to need to use the task closure. And then we're simply just going to need to say await VM dot create, like so. Cool. So now when you build the project, you'll see that you actually don't have any more errors in the project. You've managed to successfully refactor your project to use Swift concurrency. So now let's just run this on the simulator to test it out. And you can see that it fetches our people. And if I click on someone, you'll see that it fetches their data as well. So this is all working fine when you run it on the simulator. If we try and just create a person, you'll see that it successfully submits the data. But if you're eagle-eyed like me, one thing that you'll realize is that we actually do have a secret problem that might actually not be standing out to us right now. So if you actually look at your Xcode project, you'll notice that you actually have this purple warning with 4. So you have 4 runtime issues. So if we just click on it to see what's going on, you'll see that we actually have quite a few errors here telling us that we're actually publishing changes from a background thread. So what's going on here? Well, when we actually wrote our networking manager, we actually didn't place the request onto the main thread. It's on a background thread, which makes sense because you don't want to put network requests on the main thread because then it'll block your application. If you want to learn more about threading, then check out my video within this course called Threading in Swift. So what we actually need to do is we need to actually place the function, we need to mark them with the @main actor annotation. So what this is going to say is whenever we make a request on the background thread, when we're actually dealing with the UI, we actually want to place these updates back onto the main thread. So let's actually just work through this with our people view model. So in our people view model, with our fetch users, to get rid of these warnings, we're actually going to mark this with @main actor, like so. Cool. Now me personally, I prefer to actually mark my functions with the @main actor rather than placing the @main actor directly on the class, like so. So if you do it like this, what's going to happen is that every single function is going to basically automatically, well, everything is actually automatically going to be placed onto the main thread. I personally prefer to explicitly mark what functions I want to be on the main actor. So we need to actually do this on each one of our functions within our view model. So if we go into our detail view model, we just need to mark this with the @main actor, like so. And if we finally go into our create view model, we need to mark this as well with the main actor as well, like so. Cool, sweet. So let's just run this again and see what happens. And you should notice that when you're now running it this time, Xcode has this weird bug where it doesn't actually update. Or if you go to the runtime tab, you should see that you have no runtime issues anymore. And if you actually go into your view models, you should see that you don't actually have any more warnings. So we just click on someone, you'll see that we're able to fetch their data. This is all working fine. If you click on create, we'll just enter some information in. You'll see that it's okay. Cool. Now, just to show you how this would work if you had no internet connection, I'm actually just going to run this with no Wi-Fi. So obviously, if you turn off your Wi-Fi while you're watching this video, then I'm going to stop talking. So you can test this after the video. But just to show you this working, I'm just going to turn off my Wi-Fi. And then I'm going to click on a person. And as you can see that when we actually hit our timeout, you can see here that it actually changes and it tells us that something's gone wrong and the internet connection appears to be offline. So once it hits the timeout, it tells us that we don't have an internet connection, so this works fine. So this is all looking pretty good. So I'm actually going to turn back on the Wi-Fi and you should see that it actually fetches our data and shows it on the screen. So this is everything that we want to do within this video. So that's everything in this video. If you enjoyed this video, I'd love to hear your feedback in the comment section below. Also, as well, if you haven't already, I'd really appreciate it if you gave this video a thumbs up, as well as subscribe to the channel and hit notification bells to get updates for whenever I release a new video. That's everything from me. I'll catch you on a bit. Deuces.